Hello and welcome to this video on partial fractions, improper fractions. So this is the final video of 3 videos all related to partial fractions. There are 2 questions on the screen here. I'd suggest you give them a go just before you carry on. You can check your solutions below. If these are unfamiliar to you, then you should go back and watch the other 2 videos first. Okay, so what is an improper fraction? Well, an improper fraction is a fraction in which the degree of the numerator is greater than or equal to that of the denominator. Now just a reminder, the degree of a polynomial is the highest power of any of its terms. So if we take a look at the 3 fractions on the screen here, the highest power in here is 2 and the highest power in here is 3, so this is a proper fraction. The highest power is 3, 1, so this is an improper fraction. Highest power here is 2, and be careful, it doesn't have to be the first coefficient here. So 2, 4, so this one is 4, so this one is proper. Okay, now we can still split into partial fractions, but we just need to be a bit more careful. So there are 2 fractions here, they've both got the same denominator, but different numerators. So the degree of this denominator is 2, just like this one is 2 as well. Now the numerator in the first fraction is also 2. So when I divide through, so x squared over x squared, I should be left with a constant. Then I get my usual partial fraction decomposition. Okay, now in the second example, I have 3 and 2. So if I divide a cubic by a quadratic, I should be left with a linear term. So ax plus b plus c over x plus 1 plus d over x plus 2. Alright, right, let's try some examples. So example 1. So if I write this out first, so that should be minus 3. Now this one is a quadratic over a quadratic. So when I divide through, I should be left with a constant term, over my usual partial fraction decomposition. So when I multiply through, I will get x minus 1 x plus 1 plus b x plus 1 plus c x minus 1. And now we do our usual partial fraction trick of letting x equal various values. So if I equal 1, let it equal 1, a should be eliminated and c should be eliminated. So if it's 1, I get 4, add 5, 9 minus 3, 6 equals a times 0 plus b times 2 times c times 0, which then means b is 3. Okay, next one. So if I say let x equal negative 1, then I get 4 minus 5 minus 1 minus 3. So minus 4 equals a times 0 plus b times 0 plus c times negative 2. Okay, so I get minus 4 equals minus 2c, which means c is 2. Now, for the final step, if I try to eliminate b and c, I would always eliminate a here. So I have to pick a value that won't eliminate any of them. So I'll pick something easy like 0. So that means on my left hand side I get minus 3 equals a times minus 1 times 1 plus b times 1 plus c times minus 1. And tidying that up means I get minus a here. I know b is 3, so that's 3. And I know c is 2, so that's minus 2. So minus 3 equals minus a plus 1. So that means a must be 4. So our final form is 4 plus 3 over x minus 1 plus 2 over x plus 1. Okay. Okay, let's take a look at example 2. Just change the pen colour here. So 2x cubed minus 3x squared plus x plus 2 all over x minus 1, x plus 1. Now, this is a cubic over a quadratic, so when I divide through, I'll get ax plus b plus c over x minus 1 plus d over x plus 1. Take a little bit of care when you multiply through here, because there's going to be a lot of factors coming up. So I'll get ax, x minus 1, x plus 1, plus b, x minus 1, x plus 1, plus c, x plus 1, plus d, x minus 1. Okay, so we use our normal tactic here, let x equal. So if I let x equal 1, on the left hand side I get 2 equals a times 0 plus b times 0 plus c times 1 add 1, 2, add d times 0. So I get 2 equals 2c, so therefore c equals 1. Okay, we can keep going with this. So I say let x equal negative 1 now. That means on the left hand side I get minus 2, minus 3, minus 1, so minus 6, add 2, minus 4. And a times 0 plus b times 0 plus c times 0 plus d times minus 2. So I get minus 4 is equal to minus 2d, and therefore d is 2. Now, for the next one, I can eliminate a by letting x equal 0, but b, c, and d will not be eliminated. So let's see what happens when I do that. On the left-hand side, I get 2 times a times 0 plus b times minus 1 times 1 plus c times 1 plus d times minus 1. So 2 equals minus b, and I know the value of c and d, so I can put those straight in now. I get plus 1 minus 2. So from that, I get minus, so if I take this to the side, I've got 3 equals minus b, which tells me b is minus or negative 3. Okay, now the last one is a. So there's a couple ways you can do this. You can either pick a final value, a fourth value, such as like 2, or any number that isn't one of those 3. Otherwise, we're never going to eliminate b, c, and d. Now, the other way you can go about this is we can use this method of equating coefficients. So, oops, that's the wrong, I want that to stay. That's 2x. So, highlighter. So, 2x cubed is here. Now, the method of equating coefficients says that the coefficients of the variables must be the same on both sides. So, I've got 2x cubed. Now, b only has coefficients of x squared, c has only coefficients of x and 1. Sorry, this has x squared, x and 1. D has x and 1s. So this is the only one that matches that side. Now, you can expand it all out, or you can just look at the key part, which is the x's. So I get 2x cubed is ax cubed. So that means that a must be 2. Which means our final form is 2x minus 3 plus 1 over x minus 1 plus 2 over x plus 1. And that's our final term, expression, sorry. Okay, right, on to the last one now. Now, this one has got a couple of things going on. So first of all, let's notice the degree of the numerator is 3 and the denominator would be 2. So, when I expand this out, the first thing I have to notice is that I'm going to have my linear term, so I'll get ax plus b. Now, this is a repeated factor, so I'll get c over x minus 1, and then I'll also get d over x minus 1 squared. And again, just take care when you multiply up by this. It's going to be the place where you make mistakes if you rush this. Ax minus 1 squared plus bx minus 1 squared plus c x minus 1 plus d. Okay? Now, let's go and start by saying let x equal 1. Now if I let x equal 1 on the left hand side, I'll get 1 at 2, 3 minus 8 plus 8. So this just becomes 3. And a will cancel, b will cancel, c will cancel, and I'll just get d. So that's the nice first easy one, d is 3. Now, where this gets a little bit trickier is I can no longer now eliminate, really, A, B, or C on their own. I will always eliminate one of the others. Okay? So, what I can do is I can combine methods. I can put some values in where I can to get what I'm after. So let's start. So for A, I'm going to equate coefficients to begin with. Okay? And I'll tell you why shortly. So this was that method we just did in the last example. So there's an x cubed here. And the only constant that could be a coefficient of x cubed is A, because I've got ax and I've got the squared here. So I'll just highlight that entire thing. That means that x cubed equals ax cubed, which gives us the nice easy answer of A being 1. Now, for B and C, it's going to be a little bit more work. Let's start with something nice. So we can eliminate A from this anyway. So let's go ahead and do that. So let's say let x equals 0. Now if I do this, on my left hand side I get 8 equals, I get A times 0 plus B, and it's 0 minus 1 squared, so it's just B times 1, plus C times negative 1 plus D. So I now get 8 equals B minus C plus 3. And altogether, I'll get 5 equals B minus C. And I'm going to call this equation 1. You can probably tell where this is going. If I've named it this, we're going to be looking for some simultaneous equations. Okay? Now, if I let x equal negative 1, I'm not unfortunately going to be able to eliminate anything, but I'll get another value. So I'll get minus 1, add 2, minus 8, minus 8, add 8. So I'll get 17. So I get 17 equals A times minus 1 times minus 2 squared plus B times minus 2 squared plus C times minus 2 plus D. Now, let's tidy this up. I get 17 is minus 4A plus 4B minus 2C, and I know D is 3, so that's 3. Now, I also know that A is actually just 1. So I've got essentially minus 4 and 3 is minus 1. So if I bring this to the left-hand side, I get 18 is 4B minus 2C. Let's call that equation 2. Okay, now from here I've got a set of simultaneous equations. So if I lay these out, I can say 4B minus 2C equals 18. And what I can do is I can do 2 times 1. So if I do 2 times 1, I get 10 equals 2B minus 2C. Okay, so that's 2 times 1. So I'd get 2B minus 2C is 10. And if I subtract this entire thing from here, I get 2B is 8, and therefore B is 4. Which then if I put into here, it tells me that C must be minus 1. And I'm running out of room, but that means that our final expression is x plus 4 minus 1 over x minus 1 plus 3 over x minus 1 squared. Okay, so thank you for watching. If you found it useful, please like, subscribe, etc. And good luck with it all. Thank you.